So again, let me just make sure. So go down, describe what the information this graph is communicating is. The volume of a gas versus the moles of a gas. That's one way. You can also just look at the axes. So the information that's being communicated here is the relationship between the y and the x-axis. So whatever measurements are on there, that's the information that it's communicating. So we'll just put down relationship between the volume of a gas and the moles. So you can always just copy. Questions like this pop up even throughout college. You'll be asked simple questions like this that are trying to get at whether you're looking and actually reading the title that's put onto a graph. So relationship between the volume of a gas and the moles of the gas at standard temperature and pressure. So there we go. Question 2, how would you describe the line that exists when the volume and mole quantity of a gas are graphed? So we go and look at this. So we're just describing what this line is. So we're going to call that a straight line. So this is a straight line. I think I have to click on the red again. So we'll call this a straight line with a positive slope. So straight line with a positive slope. So we look at it, we see that the line is straight. So whenever you're looking at a graph, the actual line, you always want to describe it in two ways. You need to know whether the line, I guess first, you need to know whether there's actually a line there. Can you connect the dots with a smooth line of some sort? So here we can. So then you describe the line. It'll be one of two things. It'll either be straight like this one is, or it will be curved. They both mean different things. So here we have a straight line, and then the second thing you always want to look at is whether you have a positive slope or a negative slope. So here we have the line moving up, so it's a positive slope. If we had the line going down, it would be a negative slope. So we have a straight line with a positive slope. Why do we care about this? We care about this because of number 3. So what does the shape line indicate about the relationship between the two measurements being graphed? A straight line with a positive slope indicates that the two measurements, go back to the red. Two measurements are directly proportional to one another. So this is what this line is. This is the holy grail of scientific and mathematical graphs. Whenever a line like this develops, it tells the scientist or the mathematician who's doing the graphing that the two measurements that are being graphed are directly proportional to each other. The direct part means that when one of the numbers changes, the other will change in the same direction. So if one of the numbers goes up, the other number goes up as well. If one of the numbers decreases, the other one will also decrease. The proportional part tells you that they're moving by the same quantity, by the same rate. So if one of the numbers doubles, the other one will also double. If one triples, the other will also triple. If one goes down by half, the other will go down by half. That's what the proportional part means. So number 4, write the mathematical proportionality statement that represents the relationship shown. So the relationship, again, that exists here is between volume and moles. So we're going to look at the y-axis. So we have moles on the y-axis. We have volume on the x-axis. So a proportionality statement is simply written out by taking the measurements that you have, and we're going to put a fish sign in. So I call it a fish sign. This is a proportionality symbol. So it looks like a little fish. So what this means is moles is proportional. And then because this is directly proportional, we're going to write it like this. If this was inversely proportional, that means you would put 1 over whatever it is. So 1 over volume. But in this case, it's not. We have a straight line with a positive slope. So moles are directly proportional to the volume of a gas. So there's our proportionality sign right there. So our proportionality statement is saying this. All right, so number 5. So remember, we can always turn this proportionality statement right here into an equation by canceling out, so to speak, the variable on the right-hand side and moving it to the left. So what do we then set this equal to? So anytime you have any type of proportional relationship, you can always take a proportionality symbol or a proportionality statement and you can set it equal to a constant. So this mathematical constant in general, if it's just a general constant, is represented by a lowercase k. So the mathematical constant is simply the slope of the line. It's why slope is such an important concept in math. So you've been learning about slope since elementary school, not because anyone's expecting you to build a roof on a house, but because this slope is what the constant, mathematical constant of a relationship is equal to. So whatever the slope of a straight line is like this, that's the actual mathematical constant that is put into math equations that allows you to even have a math equation at all. It's these constants that are necessary. So what we can then do is we can take this. So let me copy this, and I'm going to do, this is not really a thing, but it helped me understand math better. So we can take this particular equation, or this particular proportionality statement here, and we can kind of treat it like an equation. So what I do is I treat it a bit like an equation, and I want to cancel this out. So I want to take what I have here and turn it into a math equation, meaning that I need some sort of equal sign. So I have to put an equal sign into it, but I'm not going to just put this in. So what I want to do is turn this thing into an equal sign. So again, this isn't really a thing, but what I then do and what I found that I could do is I could just cancel this out. I could treat it like an equation. So if I wanted to cancel this, because right now it's in the numerator, that means I need to multiply this side. So remember, you always do the opposite. If you're canceling stuff in math, you always do the opposite of what you want it to do. So here, I'm going to put a fraction down. So because this is, I'm actually going to put a fraction down here too. I'm going to put this in here to make it easier for you all to see what's going on. So really what this is saying is that volume is in the numerator. So if I want to cancel that out, I need to put the volume in the denominator. So here I can now cancel this. So I can just put a 1 here. Remember, you can put 1s in anywhere and it won't change. So this now cancels out. So you see these two will cancel out. So I'll cancel these out here. Again, this is not really a thing. It's something that I just made up because it really helped me understand this whole process. So I'm going to go ahead and now, since I canceled this, I'm going to move this over. I'm going to put this over here and multiply this by this side over here now. So that gets rid of this. So now I have nothing over here. So what I now can do is I can put an equal sign in, and then I'll put, again, we can always equal out these equations to a constant. So you now have a little equation that has formed. So if I want to write this down, put this in here. So we would have moles on the top, and then on the bottom here, we would have volume. And then that would be equal to a constant. And these constants will always be different. So it depends what it is you're dealing with, which relationship you're dealing with. So now you have a simple little math equation that has been created. So what you've done is you've taken an understanding of a graphical relationship here. So you've taken an understanding of this graphical relationship and you've turned it into an equation. This is where equations come from. This is how they're created. So you could now calculate this, because again, remember, this is just the slope of the line. So you could actually go into your graph and you could find out what this actually is. So that would allow you to solve for one of these spots. It would allow you to use this particular equation to solve for something that's not on this graph. So if you wanted to use or calculate the volume of a gas, if you had maybe 20 moles, so notice this graph only goes up to 4.5 moles. If you wanted to go way off the graph, this little equation would allow you now to calculate that. So going on to 7, if two measurements are directly proportional to each other, what are the two ways they could be arranged within a mathematical equation? Whenever you look at a mathematical equation, if you're dividing two numbers by each other, it means that those two variables right there are directly proportional to each other. Doesn't matter what the equation is. If it's one divided by another, that means it's directly proportional. So let's take a look at an example of that we already looked at. We can look at the density equation. So density, remember, is equal to, let me go in here, mass divided by volume. So there's an equation that we've already dealt with. And you look at this equation, this is telling you right here that the mass and the volume are directly proportional to each other. It tells you that you have this relationship here between these two because of the way that they're arranged within the equation. So again, this is all stuff that I had no idea about until I started to see it on my own. And it really helped me understand all math equations. So you can read math equations simply based on how they're set up. You can learn a lot about what's going on in them. This is one of the things that I had no clue about until not too recently. Even through college, I didn't understand this. So this is important. When you see that, it means these are directly proportional. Another way that they could be arranged is opposite each other. So if you have two things that are opposite each other on the equal sign, it means that those two variables are directly proportional to each other. So mass here and density is not really correct, but mass and density we can say are directly proportional to each other. So this right here, these two are directly proportional to each other. So if two things are divided by each other, we can look at another equation. So let me see here. So we could also look at, let's see. Yeah, I don't have another one that's really off the top. Yeah. Let's look at this equation. So another way that you can tell two things are directly proportional to each other is if they are opposite each other in the equal sign. So here's another equation. This V and T are directly proportional to each other as well. So because they're opposite on opposite sides of the equal sign, they're directly proportional to each other. So that's another way that you can tell simply by looking at a math equation what the relationship is between two or more different measurements. All right, so there are the answers to those questions. Like I said, I wanted to go over those parts, and it is review. So that's the basis for Avogadro's law. So this is where the law came from. So his discovery that 1 mole of any gas will occupy 22.41 liters of volume is a result of this type of work here. So that's why I wanted to put that review on there.